So yeah, we have collaborated everything. Yeah, duct system we have created. We can go to the mechanical settings, EMS. The offset we have assigned. Okay, rectangular duct sizes we have corrected. Shoe branch we have created. We will join, yeah. Now we can go for automatic routing. And after that, we can go for manual routing as well. Okay. So like I'll be placing the fan coil unit. So you can go to the mechanical equipment. Let me place the fan coil unit there. Actually, the fan coil unit, I have placed 500 mm above the ground floor ceiling level. Okay. Now, once you have selected your fan coil unit, it is having an outlet and inlet. Outlet is supply, inlet is return. So select the outlet, the duct will come. You can select the duct, find the middle elevation of duct, correct, 754. We already found this before. Means with respect to the ground floor ceiling level, the central line of duct is 754. Okay. And I'm placing a few air terminals. I'm selecting the air terminal. And first air terminal I am placing here. Second one I am placing here. The third one I am placing there. Fourth one I am placing here. And after that, the fan coil units has to be connected with this one. Air terminal I have placed exactly on the ground floor ceiling level. Now you can see it is having an elevation of -100. No. Air terminal has to be placed exactly on the ground floor ceiling level. So that's why the elevation from the ground floor ceiling level should be 0. If you are providing a positive value, means 100 mm, from the ground floor ceiling level, 100 mm above this will place. If you want to take it downwards, you can provide a negative value. But exactly on the diffusers, we will be placing exactly on the ground floor ceiling level only. So that's why the top of some offset we will be providing, this elevation we will be providing 0. If you want to generate the automatic routing, the first step, we have to create the system. We have to create a system. To create the system, any diffuser or machine within that you have to select. Okay. So I'll be selecting the diffuser. And after that top side, you can find the create system option. From the create system, you can select duct system option. Okay. Then from the duct system, it is asking whether that is supplier or fresher. I am selecting supplier. Then the system name, I'll be selecting, let's say that is test 1. Okay. Now there is an option called open in system editor. For time being, I'm not selecting it. Rather, I'm clicking OK. Now this diffuser is the part of supplier system. That's why it is having the same color of supplier duct. But all the other things also you have to add along with this system. So when you are selecting this diffuser, you can see there is duct option. But if you are selecting this one, the duct option is not there because it is already a part of system. So if you want to add this diffusers and this machine along with this system, you can select the diffuser under the system. Top side, we are having duct system option. Go there. And after that, what system you need to select? Test 1 only. Go to edit system. And after that, here we are having an option called add to system. Add to system. Select this diffusers. Then select equipment. Select your equipment. Finish it. Correct. Means first you have to create your system. To create the system, any diffuser you can select, go to duct system. Okay, you can provide the name. Let's say that is test 1. Click OK. Now you can select the system diffuser, then go to the duct system. Select what system you need to edit. Just go to edit system. Select the diffusers under the system. Select the equipment. It means add it to system. You can add those things. Select equipment, select it. Now finish it. You can see everything under the system only. Okay. Otherwise, you can do one thing. You can select the diffuser under the system. Go to the duct option. Let's say that is test 1. Here we are having an option called open in system editor. Open in system editor, if you are directly selecting, you will be getting the select equipment option, everything here. Open in system editor, click OK. Now you can see add it to system. Add it to system. Okay, this diffuser I have added. Select equipment. Oh, this I have missed. Oh. So I have missed that one. No problem. Any diffuser under the system you can select. Just go to the duct system, edit system, add it to system, select it, finish it. Correct. Everything you have to create. Now the system code creator, you can place your mouse pointer above anything under the system. Click tab key. Tab. So it will highlight the system. So this is our system. Correct. That's a system code creator. Now you can try your automatic routing. Okay, automatic routing either in the floor. Here you can try just when you are selecting any diffuser within the system. There we are having generate a placeholder, generate a layout. I need generate layout only. Placeholder means single line. I need generate layout. So select it. You'll be getting different route there. Which route you like, that one you can take. Correct. Or you can go to the 3D. Okay. So any diffuser within the system you can select. Go to generate layout. So few loop you will be getting. Okay. Now you can do one thing. Just go to the settings. After clicking the generate layout, go to the settings. Main duct type, that is rectangular duct, radius elbow, shoe joint only. Middle elevation. This is very important. After placing the machine, I have found already that is 754. That's why it is 754. In the mechanical settings, I have given this one. The offset is not proper, the ducting will not come. Branch duct also, the duct type is rectangular duct, radius elbow, shoe joint, and 754. Click OK. We are having a different routing options like network, perimeter, and intersection. These are 3. Perimeter will be good for fire protection and all. Network and intersection, you might be getting good duct routing. Just go to network, route number 1, route number 2, route number 3, route number 4, route number 5, correct. Route number 6. If you are going to the intersection, route number 1, route number 2. Intersection route number 1 and network route number 6, same route only. Okay. If you like this one, you can finish it. You will get that one there. Correct. Control is it? Cancel. Once the system is ready, you can select anything under the system. Go to the generate layout option. You'll be getting different route. Now we are having 3 routing option. I like route number 6. Just to finish it, the route will come. Correct. Or you can do one thing. Select it, generate layout. Okay. Network route number 1, route number 2, route number 3. For in case like network route number 3, if you need to edit. Network route number 3, if you need to edit, you can go to the edit layout option. Edit layout. After that, you can click the duct. Then you can move it slightly. Yeah. Then you can go back to the solution. Now you can see there is one more solution type custom. There is edited only. So if you like this one, you can finish it. You can finish it. You'll get that. Yeah. Correct. Here you can see we are having an elbow connection. This is not the way it has to connect, but automatically like that only it will come. But in case like if you need instead of this one, which one? a rigid connection, if you need a flexible there, you can go to the system. Within the system, there we are having an option here, no? Convert to flexible duct. Convert to flexible duct. Select that one. What's the maximum flexible duct length? As per SMACNA, you can go up to 1.5 meter, 1500 millimeter. Now it is 1200 only. Okay, keep it there. If you want to change it to 1000, provide it. And after that, select the diffuser. You can see. Correct. Means you can come to the system, but plenum box and all, it won't come. You can go to the system, convert to flexible duct. What is the flexible duct length? You can provide it here. And after that, select the diffuser, it will come. Correct. Yeah. That's it. Or in the starting itself, if you need flexible duct, we can. Even in the starting, at the time when you are routing it, in the terminal side, if you need flexible duct, we can take that. You can select the diffuser under the system, go to the generate layout, go to settings, branch duct. Here you can see the flexible duct type is none only. That's why rigid connection is coming. Flexible duct type, you can provide round, and the maximum length of flexible duct, let's say 1200, maximum 1500 only. But as per your requirement, maximum how much? No, I need like 1200. Click OK. And after that, for example, route number 6, I like. Finish it. So instead of rigid connection, every terminal side will be getting flexible ducts. Okay. Or rigid connection, generate layout, you can go to settings, branch. Now the flexible duct type is none only. So now click OK. Finish it, you will be getting the rigid connection. Rigid connection, if you need to change it, you can change that into convert flexible duct into rigid, or convert duct into flexible duct. Okay. Fine. I'm doing one thing. I'm just going to the ground floor ceiling level. Create similar. One diffuser I am placing here. Another one I am placing somewhere there. These two diffuser also I am adding along with this same pattern. So just select any diffuser or machine under the system. Go to duct system, test one, edit system, add to system, add this two, finish it. Now the ducting might be slightly complicated. Try to get a route there. Select any diffuser under the system. Go to generate layout. Correct. These kind of routings and all, that is not practically possible. Correct. You're not getting a good loop there. Correct. This and all, it is not possible now. So that's why automatic routing you will get when the duct routing is too easy. Otherwise, if it is a complicated one, you will not get it. Automatic routing will not help when you are working. It's just an option, logical routing. But we can edit it. Just go to generate layout. For example, route number 5, 4, 3, 2. Route number 5, I'm just editing it. Go to edit option. Finish it. Like that, by editing it, adjusting it, you can make it. Also, trunk dimension common only you will get. It will not be decreasing after the tap off and all. Okay. So that's why. This is a way automatic routing we can try, but I don't think it is very useful. Now the system that you have created, now manually only I'm just going to try now. The system that you have created, now we can delete it. Okay. So I'm just, if you want to delete the item, you can delete everything. After selecting this everything, you can click and delete it. Otherwise, you can do one thing. You can go to the view option. From the view option, just go to the user interface. From the user interface, there is an option called the system browser. Just go to the system browser. Okay. From there, you can select systems, mechanical, supplier, this one, test one. This can go to the system browser under the view section, select system, delete it, right click and delete it. So the system I have deleted. Now this is not the part of supplier system. You can select it and delete it. Done. Okay. So now what I'm doing, I'm not having a reflected ceiling plan. In reality, when you are working, the RCP you will get from the architect. It means tentative location of diffusers you will get. But here it is not there. So I'm just going to place the diffusers. Project, import GBXML. This is a file. Open it. So now which location it is? Okay, I'm just going to this. In case like if it is Dubai, so we can go for Middle East, location UAE, Dubai. Fine. But you can go to the latest climate data. You by the help of Revit also, we can do the heating and the cooling load analysis, but that is not proper. Okay, it is not accurate. It is not a design tool. Okay, you can select the latest station, Asia, United Arab Emirates. Okay, then you can find Dubai, 0.4% case, Dubai, 0.4%, 43.3, mean constant wet bulb is 23.6, 43.3, 23.6. So 43.3, then 23.6. Hottest month the dry bulb range is 9.2. 9.2. Rest all the values I'm keeping same. Click OK. Come to the space, ground floor office 1. Ventilation separate AHU only we are proposing. So the ventilation I will not be incorporating there. Let me make this as a medium building like 341.8. Internal lighting load is not there. Okay, so LPD value we can try. We know that. Electrical equipment, we can try that. Number of people we know from the furniture layout that is 12 only. They're doing like office work. Walls window, keep it there. No need to change it. Roof and skylight, not mandatory. It is not exposing to the outside. Infiltration, 0.5, 0.5 for time being. ACH. Okay. Then floors, slab floor on grade only. Partition is not there. We can go to the system, create a new system. That is our ground floor office 1. You can keep undefined the system component, ventilation air, make sure that is 62.1 2010. Yes, it is a duct system. So the duct heat gain 5%, duct leakage 5%. Add ground floor office 1 within the system. Go to the thermostat, create a thermostat schedule. Okay, let's say that is 24-hour schedule. Okay. And the cooling thermostat set point is 24 degrees Celsius, 50% relative humidity. Sizing data, cooling sensible, let's say 10%, cooling latent 5%. Click OK. Right click, print and view, design result, preview. Yeah. So in the, it will come like a 7.2 kilowatt, 578 liter per second. Okay. So just more copy. Then total coil load directly we will be getting there. Total coil load, we are getting 7.2 kilowatt. 7.2 kilowatt. How much ton it is? 7.2 divided by 3.516. That will come like 2 tons of refrigeration. Now we are directly getting the airflow rate. Airflow rate is 578 liter per second. 578 liter per second. How much CFM it is? Liter per second multiplied by 2.119. So this much CFM. Then from the catalog, we have selected NC value is 40 decibel and delivery velocity we can go up to 5.5. This is actual value. And this also you can follow. Okay. This was the thumb rule that I have explained, but the correct method, only one room at least we can try for this one. Okay. Now we have to propose the diffusers. If you have already received a reflected ceiling plan from the architect, that's tentative location of the diffuser we will be getting there. But unfortunately, for time being, we are not having anything. So we can do a hit and trial. Now I'll be proposing. For example, what is the size of the ceiling grid? Since it is a square ceiling, square type diffuser we have to propose. That is 600 by 600 only. So in the terminal selection class, we have already studied what is the overall outer flange dimension of 600 by or in a 600 ceiling we can propose now. Anyhow, see the standard neck sizes that we are having as per Airmaster catalog, that will be starting from 150, 150, 225 by 225, correct. Multiples of 75. See, up to 450 neck, I'm not repeating this much because already we have studied. If you are going to the ceiling diffuser, up to 450, the neck size it will be available from 600, 600. 525 by 525 and 600 by 600 neck. Outer flange 600 is not possible. Correct. Because neck sizes, it is available from 150, 150 to 600, 600. But up to 450 neck size, the outer flange dimension we will be getting from 600, 600. 525 by 525 and the 600, 600 neck size, the outer flange will come higher than that. So it will be difficult to place there. In this 2 feet false ceiling, the maximum possible neck size we can provide is 450 only. Let's say, so the neck size I'll be assuming, for time being, neck size I'll be assuming 450 by 450. 450. Okay. Now I'm just going to the Airmaster catalog or any diffuser selection catalog. I'm selecting 4-way type, 2-way, 3-way, 4-way. 4-way type, 400 into 400, 400 into 400. How much CFM we can deliver? Anyhow, delivery velocity doesn't matter there. We can go up to maximum, how much? 1 second. We can go up to maximum 5.5 meter per second. Correct. But 450 neck size. Okay. NC value we can go up to 40 decibel. NC value 15, 20, 30. NC value 36 you can select. NC value 36. Delivery velocity we will be getting 2.5 meter per second. Maximum 40, just keep 36. How much CFM we can deliver? 1071 CFM we can deliver. Okay. 1071, I am fixing this one. CFM per diffuser. So the CFM per diffuser, CFM per diffuser is 1071. Then the number of diffusers will be number of supply diffusers will be total flow rate to deliver is this much. CFM of one diffuser is this much. How much? 1.14 number of diffusers we required. 1.14 is not practically possible. You can round that into 2 numbers. Okay. So that's why when 1224 CFM, when you are rounding that into 2 numbers of diffuser, again, the CFM per diffuser will vary, right? Now the CFM per diffuser is, before it was, I just assumed the maximum possible neck size. So we got 2 numbers, actually 1.14 only, but when we are rounding into 2 numbers, CFM will vary, right? Now, 1224 CFM we have to distribute by the help of 2 number of diffuser. So each diffuser should have a 612 CFM. Okay, 612 CFM, 612, just 612 CFM. Now we can come there. In a diffuser, we have to deliver 612 CFM, NC 40. 150, maximum 167. 225 by 225, maximum 375. 300, even 572 CFM, NC is 38 only. 667 CFM, NC is 43. Our NC maximum, we can go up to 40. So 612 CFM, we can interpolate, you know how to do it. I have explained that one, but I'm not taking the risk. 375 by 375. 595 CFM, NC is 28 only. So 612 CFM, NC will be 745 CFM, NC is 35. So definitely in between, only the 612 will come. So the NC will be between 28 and 35. We can go up to 40. Delivery velocity between 2 to 2.5 only. So what neck you can select? 375 by 375. So the next size we need, next size we required 375 into 375. It's a 375 into 370. It's a hit and trial. Means we have assumed 450 and the approximate number of diffuser we have calculated. Then we rounded the next size. Okay, this is one option. With respect to the maximum possible grid dimension, the number of diffuser we can propose. The next option, tentatively we can find, for example, as per the fault ceiling. Say I'm planning to propose 3 supply. For example, 1 supply here, 2 supply here, the third one here. Distance between the supply diffuser, as you know, how we have to decide. Distance between the diffusers is totally depending upon the terminal velocity, 0.25 meter per second, the throw only, based on the throw. But for time being, I'm just coming to the system. One I'm placing here, the next one here, another one. So 3 supply, 3 return, like that we can propose. Let's say. So let's say the number of diffusers, number of supply diffusers, 3 supply. Then the CFM per diffuser is 1224 divided by number of diffuser is 3. 408 CFM. Now you can come to the AMAS catalog, 4-way diffuser, 408 CFM. 408 CFM. So 408. No, it's not possible. 300, 476 CFM, NC is 33 only. We can go up to NC 40 for this case. Delivery velocity is 2.5. What next size we can select? 300. We can select the next size of 300 into 300. Both the way you can do. Or with respect to the liter per second per square meter data, or the cooling air changes per hour data, any method you can find to propose the type of diffuser. Anyhow, since it is a grid type ceiling, square ceiling, so we are proposing square diffuser. But rarely, normally, when you are working in a company, the type of air terminal, what shape it should be having, no, the architect will propose it. Because square, as you know, like we have already studied all those things, I am not repeating it. Okay, anyhow, since the number of diffusers, I'm just going for 300, 3 numbers. So I can include like 3 number of diffusers. Okay, 300. Now just coming to the model, I'm selecting the air terminal. So just select an air terminal. When you select this one, if you want to make it like a 2-way, if you want to make it like 1-way, 3-way, all those things are possible here. Correct. So I'm selecting an air terminal. I'm selecting a supply, exhaust return supply, square only, 600 overall size, 300 connection. The same I can use. The same. 300 only I required. But if I'm proposing 2 supply, 2 return, then I required 375. But 3 supply, 300. 2 supply, that is 375 is fine. So anyhow, I'm proposing 3 numbers. So select the terminal. Okay, I'm not editing the original. I'm just duplicating it. Select this. Go to edit type. Duplicate it. Okay. So like 300 neck and 600 overall. That is my supply square diffuser only. SCD, SD, any shape number you can. So duct width is the neck only. Duct width is 300, 300. Diffuser width is 600. If you want to change it to 375, you can change accordingly, but I need 300 only. Default elevation is 0, means exactly on the ground floor ceiling level we have to place. Apply. Okay. Okay. You can see. And what is the flow? That is 235 liter per second. 235 liter per second was the preset flow, right? But in our case, how much it is? In our case, that is this value CFM only divided by 2.119. That is 192.6 liter per second. Let's say 193 liter per second. You can come there. That is 193 liter per second. But if you want to make this like CFM, you can do that. You can go to unit, UN, or you can go to the manage option, settings panel, okay, project units. Then HVAC, airflow rate. Now it is in liter per second. If you want to make it like a cubic feet per minute, there you will be getting CFM. Okay. Select it. And the pressure drop, when we are doing the ESP calculation, we required that value. For time being, I'm not changing it. Create similar. So one number I am placing somewhere here. We can change that later. Another one here. Third one somewhere. Here. Okay. The same way we need to place the return. Just go to the system, air terminal, return square diffuser, go to edit type, duplicate, return square diffuser, 300, 300 neck, 600, 600 overall. Okay. And place it. Two supplies should not come together. Okay. Now just align this with the false ceiling. Just align this one, this one, this one, this one. If you need to replace this one at the time of coordination, slight changes is possible. Okay. The same way, every space we have to do this. Correct. Accordingly, you have to do. Anyhow, for time being, for the next space, I'll be copying this one. Select it. Make sure only the air terminal has selected. Copy. I'm just copying this one. Okay. And with respect to the base point, I'll be placing it to the next space as well. Okay. So the alignment is not proper when we are copying from some other spaces now. Yeah, now it is fine. We have to realign it. Okay. Now we can do one thing. Since we are having a multi-student, this is ground floor, first floor, third floor, second floor. For this floor, I'll be proposing a single machine only. One machine. And by the help of VAV boxes, I will be planning to propose both the spaces. See, I did heat load of only this space. The same way, heat load of this space also has to be performed. Okay. Because this room, we are having only one side exposure. Only this side is exposing. But for this room, we are having two side atmospheric exposure. So the coil load will be slightly more in this room. Ground floor office 2. Okay. Anyhow, for time being, just let me do that. It is not a design class. Design class in depth, we have already studied in the project session and all. So we can continue. So I'll be placing my fan coil unit there. And after that, I'll be doing the manual routing. Just go to the systems, mechanical equipment. This. Okay. So I'll be placing somewhere here near to the wall. You know, it is taking the return from the backside only, since it is an open return. Minimum distance from the obstruction 300 mm. So move it towards 300. And from the ground floor ceiling level, the tentative elevation means from the reference level to the bottom of machine, I am providing 500. Elevation from the reference level, it is 500 only. Okay. And by the help of single machine, if I am planning to provide airflow rate in two different spaces, I need a VAV box there. VAV box. So a bypass type VAV also I'll be proposing in between. Fine. Okay. See, we can do the modeling now. Duct sizing also, it is possible that we can adjust later. Select it. If you want to start a duct from the machine, the easiest option, you can click here, the duct will come. Or you can click here, right click here, draw duct, rigid duct will come. You can click here, right click here, draw flexible duct. You'll be getting the flexible duct from that machine mouth. Or you can click here, right click here, draw duct, then also the same property will come. Or you can go to the system, select the duct. By the help of duct, you can move it. When your mouse pointer is picking it, it will show like this. Then click it and make it, the duct will come. Different options. The easiest option is click here. Anyhow, the starting duct dimension, the width I am taking like a 600 or 650. Height I am maintaining like 500. I don't know how much it is. With respect to the flow rate, we have to size it. You know how to do the duct sizing and all. Equal friction, velocity reduction, static regain. Okay. So let me make the duct. That is my starting duct. The type of duct is shoe only we have selected. So bevel joined. Now different connections we can explain. Automatic routing there was using like a elbow. It is not practically possible always. Here we can connect using flexible duct. Rigid connections we can try. As you know, since this one, I'm trying a rigid connection. Since this is having an offset of 754 middle elevation, the duct one. See, this one is having a neck size of 300. So what should be the minimum width of duct? From the bottom of duct, we have to place the duct, and after that we have to hammer it, no? So that's why the duct width should be minimum 350, then only we can connect it. So just create similar. Width of duct I am providing 350. Height of duct I am providing 250. And after that I am starting from there. Then I am placing it here. Like this. This is an elbow only. If you want to make this elbow like a T-joint, you can click here. Then you can start from here. Or you can click here. If you want to continue towards this side, you can start towards this side. Correct. Now it is 1.5 times width, the throat radius. But I need that is 1 times width, so that I'll be getting a small one. Now you can go to the align option. Align option. Align this. Center line is okay. Now if you want to connect your diffuser, the easiest option. Select your diffuser. See, select this one. This is shoe type only. We have already loaded the beveled joint. So select your diffuser. Top side you can see there is an option called connect into option. Select connect into option and select the duct. The connection we will get. But the problem, since it is having a shoe connection, that shoe connection you will get. The shoe connection you can provide in the opposite side. For example, if you need that to that side, like that you can provide it, no problem. But normally, if you don't want,